All right, welcome to our lesson on composition of functions. I'm going to expand this a little bit. And we're going to start with a little review. What does it mean to evaluate a function? That means we're given something in function notation, and we are replacing the x's with the value that we're given. So you guys have been doing this since Algebra 1. Hopefully this feels familiar. A function can be labeled with f, a function can be labeled with g, but it has that g of x or f of x notation. So problem number 1 says go to the function that's labeled f, and everywhere we see an x, we're going to replace that with 5. Remember that this instructions here do not participate in the equation. We just want to simplify what we get when we plug 5 into that equation. So we've got to remember a little PEMDAS. We're going to square first. Then we're going to do this multiplication, and we're going to get 93 as our answer. And so we could write f of 5 equals 93, or when we plug in 5, we get 93. That is a point on that graph of that function. So using our function name g, same idea. We're going to go to our absolute value, and where we see the x, we're going to replace that with 15. Remember that absolute value functions like a set of parentheses. So it's the absolute value of 7. We do the inside first, and that's positive, so it stays positive. That is our answer. We could also write, that's g of 15 equals 7, or we could write an ordered pair. We plug in 15, we get 7. So when we compose functions, the idea is the same. We're going to be plugging something in, and when we do that, we get a new function. And the composition of function is typically written this way: f of g of x. So this first notation here means that we would take the entire g of x function, whatever that is, after the equal sign, and plug it into f. So we want to work with the innermost as well. These two are the same. This is the same notation. When you see that open circle between two function names, it means plug g into f. So that's a little bit advanced. We're going to start with numbers. When we have a number where the x is, if we have a number in, we are going to get a number out. In other words, our answer will be a single number. So that's a good thing to know. This says go to g and plug in the value of -2. So here's our g function. We're replacing the x with -2, and then we're just remembering PEMDAS. So we get a 4 here, we get 12, and we get 16 as our answer when we plug -2 into g, right? Same thing we've done before. Now we'll see in B, this is a composition. We have two functions layered together. We want to start with the innermost function first. We want to figure out what is g of -2. Well, guess what? We already did that, right? We did that in A. So I already know that g of -2 is the same as 16. So I could rewrite this now. What is f of 16? Because g of 2 is the same as 16. Those are equal. So we take the output of the innermost function, and then we plug that into the outermost function, which is f. So we go to f, and where we see the x, we replace that with 16. We do 2 times 16, and we get 32, which is our final answer, number in, number out. We could also write that as f of g of -2 equals 32. Then we go to these two problems, and you'll notice there are no more numbers. So that means that we have to take the entire g of x function and plug it in to the f function. So another way to write this, because we don't have a number, is that we are going to go to the f function and we are going to plug in everything that is g of x, 3x squared plus 4. These are saying the same thing. The g function goes into f. So now we're going to go into f. We're going to replace every x we see with this whole expression. It's really important to use parentheses so that we get the right answer. So we're going to multiply 2 times 3x squared plus 4. That requires the distributive property. Remember, this is going to come over and multiply by the 3 and the 4, so that our answer is 6x squared plus 8. So when we plug g into f, we get 6x squared plus 8. Here's that open circle notation, g of f of x. F is going to go into g, the order matters. So we could also write this as g of f of x. And we could also write it as going to the g function, and everywhere we see an x, we're going to replace that with 2x, because that is the f function. So we're going to g, and everywhere we see an x, we're going to replace it with 2x. Remember to use parentheses. And then remember, we should simplify using PEMDAS. So what we need to do is simplify the exponent first, and we need to square the 2 and the x. That's 4x squared. We need to multiply. And since we can't combine those two terms, that is our final answer, g of f of x. Now for right now, since we're not looking at pictures, do not worry about the domain. We will address that later when we compose some more functions. Okay, so here are some examples with 3. And again, in A, we've got f and h number in. We're going to get a number out. So we're going to go to the h function first and plug in -2 and see what we get. So we look up here for the h function. That's -3 times -2 squared minus 4. And I'm going to go ahead and simplify that first. -2 squared is positive 4. -12 minus 4, -16. So h of 2 is the same as -16, which means in step number 2, we're going to go to the f function and replace the x's with -16. So we're going to do our multiplication first. That's -32 plus 9, and -23 is our final answer. So we could also say f of h of -2 is -23. A triple. So we're going to have to do the plugging in 3 times. We start with the innermost. So I'm going to do h of 2 first. Plug 2 into the h function. You don't need to see that again. We'll just simplify. When we simplify, we get -3 times 4 minus 4, which gives us -16. So this is the same as -16. Now it has to go into g. Make sure you're paying attention to g because there's a negative first, and then we're replacing x with -16, and this is still happening inside absolute value. So when we simplify that, we end up with the absolute value of 16 plus 4. Opposite of a negative is a positive, and that gives us an answer of 20. Now that 20 has to go into f. You see there's a third function there. So we are starting from the inner and going outer. So now we're going to go to f and plug in 20. And that would give us 40 plus 9, or 49. That is our final answer. And we could also write that f of g of h of 2 equals 49. All right, so a little extra practice without the numbers. In C, we're going to plug f into h. This might also be written h of f of x. So circle or parentheses asking us to do the same thing. That means we are going to plug all of f of x into h. So we could write that as h of 2x plus 9. Go to the h function, and everywhere we see an x, use parentheses and replace that. with f. Now, this is going to recall some of your Algebra 2 knowledge. We need to square this binomial first. So I'm going to give myself some extra room to do that. So remember here we have to FOIL, first, outer, inner, last, or make a box to multiply that. 2x times 2x is 4x squared. 2x times 9 is 18x. 2x times 9, another 18x, and 9 times 9 is 81. And then we're going to subtract 4 at the end. Now that's everything we got from multiplying, but everything on the inside still has to be multiplied by -3. And I'm going to go ahead and call this 36x, just to add those like terms together. That gives us -12x squared when we distribute the -3 in by multiplication, minus 108x minus 243 minus 4. And our final answer when we plug the f function into h would be -12x squared minus 108x minus 247. So we're going to combine those like terms for our final answer. And the triple substitution can be done with a composition of functions as well. We're going to plug h into f and see what that gives us, and then we're going to take that answer and plug it into g, inner to outermost. So the first thing we want to do is go to f and replace everything in f with -3x squared minus 4. The order that the functions are written in is important. In this case, h goes into f. So that's 2 times -3x squared minus 4. And that gives us -6x squared. I forgot something. I forgot plus 9. Sorry. That gives us -6x squared minus 8 plus 9. Forgot to finish the function. Apologize for that. So there are like terms there. We can simplify -6x squared plus 1. So that's the first step. That result has to go into g. So using our absolute value symbols, and really important to use parentheses. There's our negative sign, and here's what's going to be substituted for x. -6x squared plus 1, and then a plus 4, and then we close absolute value. So that negative that was present in the g function distributes to both parts of what we substituted. So it's the absolute value of now positive 6x squared minus 1 plus 4. And that gives us the absolute value of 6x squared plus 3. And that is our final answer. We cannot simplify that anymore. We don't know what x squared is, so we can't take it out of absolute value. So let me make that a little bit clearer that that's absolute value. That is our final answer. So starting from the innermost and working to the outermost. So as you finish your notes, you're going to see these next two problems. I'm going to set them up, and then I want to make sure that you can simplify them. So in number 1, g goes into f. So we'll be plugging 2x plus 1 into the f function. And that's going to look like this. X is in 2 spots, so that has to replace both x's. Do you see that? This x and this x both have to be replaced by 2x plus 1. Now we have to FOIL. That's what we want to pay attention for using our algebra and algebra 2 skills. So first, outer, inner, last. First, outer, inner, last. And then this -3 is going to distribute -6x minus 3. So that's everything we get when we multiply. We're going to combine like terms. The x's can all go together. So 4x squared minus 2x. So there are 4x's here and we're subtracting 6. And then the 1 and the negative 3 can go together. So minus 2. That is our final answer when we plug g of x into f. And this last one might look a little strange, but we're just going to do what it says. That's what function notation is, set of directions. We're going to plug g into itself. So what does that look like? We're going to go to the g function, and everywhere we see an x, we're going to replace it with the g function, which is 2x plus 1. So the g function starts with 2. Here's our first x. So right into itself. And then we simplify as we've done all along. We're going to distribute the 2 to get 4x plus 2 plus 1. And we get 4x plus 3. And that is composition of functions.